All right, so welcome to this series of workshops in Paradox 24. And with that, let me give you the heading of today's workshop. I'm sure all of you know, but it is going to be rapid prototyping for data-driven web apps, right? And before that, before we start on this workshop, let me just introduce you to the speaker of this workshop, Mr. Jaidev Deshpande. Okay. So Jaidev is the Associate Director of Technology at Graminer, okay? And he is a full stack data scientist who specializes in building ML and AI products and the tooling around them, right? He has a decade of experience in scientific computing, media, healthcare, and the public sector. He has authored a few international papers and book chapters in signal processing and scientific computing. He teaches ML and data visualization courses on platforms like Upgrad and Springboard and Talent Sprint. All right, so this is about our speaker for today. I hope you have good time with this workshop and we can continue. Okay?
All right. Please come and occupy the front rows as much as possible. There's not too many of us, so I think we can, well, I certainly am a lot more relaxed than I was half an hour ago. And what others didn't, like others gave a very formal introduction. I'm also a BS level student.
Yeah.
So,
I would like to add. So,
I mean,
so I hope you might be seeing his name on discourse and all many at many places.
I think that's more than 6 months ago.
Yeah. So even in the courses like some big answers and all. So you might be seeing his name. So he is one of our I think 2022 20
21.
21. So yeah, he is from first batch, and yeah, currently he is about to complete. Yeah, he is about to complete his BS degree. So yeah, I think yeah he will add more.
Thanks. It looks like none of the first batch people are here except, I mean, at least, yeah, none of the first, anybody who's 2-1 F1 roll number, okay, cool. That's good, that's good, because if you were from the first batch, then, you know, whatever it is that I had to say to you, I've probably already said. How many of you have finished Intro to Python? Please raise your hands. Perfect. Oh, keep them raised. MAD 1. Okay. MLP. All right. Okay. So the two of you know exactly what I'm going to say for the next 1 hour, but the four of you. All right. The idea for this workshop essentially came from this ML as a service product that we were building, and what happens is that as you chase the development of one product over, let's say, a period of more than a year or 2 years, it takes about 6 months in a smallish team to bootstrap that product. Then you start getting, you know, alpha users, beta users, and then you start getting real paying users. And when you hit that step, that's when they start reporting bugs. Oh, bugs are easy to, of course, I mean, bugs start coming in a lot sooner, but these are like real bugs from real users which straight away impact your revenue. So you need to figure out a way to sort of cycle back and have alternating release cycles. So we typically, in most agile, anybody doing software engineering, software testing in their final years right now? Okay, good. So typically what we do in agile is that we alternate between bug fix releases and feature releases. So when a bug is reported, we say that, okay, it's noted that the bug is reported, we are not going to fix it now. We are going to fix it in the next release, right? And when that one release happens, then the next month you do a feature release. So at this point, the bugs are usually easy to fix, but I mean, again, relatively easy to fix. It's not always very easy. But as more and more features come in, you have to really take a very long and hard look at your architecture. You have to go and think about how you could have done things differently to sort of include this new set of feature requests from the users. And that is when you do what is known as refactoring. Who knows what refactoring of code is? Wrong answers are perfectly fine, and there is no wrong answer really. There is no definition as such of free.
Is it like reviewing the git push?
That's code review. It's a part of refactoring, but not really. I mean, by simply doing that, you don't refactor code. So factoring is in the same sense as factorization. So what happens when you factorize a matrix, right? Or, sorry? Break it down, exactly. So, when we do PCA, what happens is that you are trying to find that, let's say your data is n dimensional, and you're trying to find a k dimensional representation of the data where k is much less than n, right? And what you do is that you think, or you hypothesize that all of the information that is there is present in those only tiny 2 dimensions or k dimensions. You don't really need all the n dimensions. You can afford to throw them away. So this is factorization, or this is also called diagonalization of the covariance matrix and all that, right? This you must be knowing from MLT and all. Code refactoring has a very similar interpretation. It's not literally the same thing, but it's a good analogy. Code refactoring is like doing PCA on your code. You're throwing away things that don't matter and expressing your code only in terms of things that matter, right? And after you have done multiple bug fixes we do something called monkey patching. Has anybody heard that phrase? It's essentially, okay, I see some hole in my application, I stick a sticker on top of it and it looks ugly and everything. I hope the users won't notice and I continue with my life. After 3 release cycles, you see that the application is just a series of patches. You don't see the shiny finished product under it, right? So this is when you go and refactor things, but you can't take off the patches because things will start flowing out of, right? So this is when, you need to develop an intuition for, well, first of all for refactoring, and this is where rapid prototyping comes in. How can I quickly put things that are in place which I can test and iterate over quickly? And one recipe that usually works and that, most people have discovered the hard way is that whenever you are in trouble in refactoring, follow your data. And especially who has finished MAD 1, MAD 2 projects? Well, let's say MAD 1 projects. Okay, 1, 2, 3. Okay, same fellow, right? It's like, how did he teleport over there? Cool. So when you end up in the modern application development course, Adarsh is not here, right? He stepped out. Okay, fine. You will have to do similar sort of stuff where you will be building web apps which have some sort of a data backend, right? And pretty much anything is data driven nowadays. The example that we are going to deal with is machine learning as a service, because there is no application of data that is, well, as intensive as machine learning. There is, of course, things like a blog. What are the kind of MAD 1 problems we have had? When I did it, it was flashcards. Later, it was something like, I think it was making a blog, and then there was something like Make My Trip. What about you? Music streaming apps, right? So these are all data-driven applications. It's not like they are not. Of course, I mean, if you were to make something like a game like Wordle or something, or you would get to make a game of Snake on the web, that's not data-driven specifically. But most things, you have users, which means you need to store something for them. Users will create their own data. You will be integrating with various services and all, and you will be generating data. So apps generally are data-driven. Out of this, machine learning tends to be so much more data-driven that it serves as a good example of what data-driven apps are. So that's what we're going to do today. We are going to try and build a simple web service that does, let's say, scikit-learn, right? How many of you are familiar with scikit-learn? I think only a few people have done MLP, right? Okay, great. So here's the thing. Do we have, yeah. This is typically what, is this required or can I just erase this? Okay, how many of you have a laptop? And did you receive the instructions for the workshop? Because this was meant to be like interactive, like we talk and we code and we talk a bit more or something like that. Okay, so feel free to share laptops between you because you are going to be either orally or literally coding. Or we'll do prompt engineering. You prompt and I'll write the code, whatever it is. Something like that. Okay, great. So in any case, I don't think, if you need to set this up and run the code yourself, please go to this URL. Anybody who has read this README file yet? I think this URL has been up for 30 minutes now, about. Okay, cool. So, typically what would you expect in a machine learning as as a service application? Think of something like Amazon SageMaker or Google Colab even, you know. Although Google Colab isn't technically MLAS, but it's close. I mean, you can, it's a really good product and which puts together a bunch of different things. So when you want to expose machine learning capabilities over the web to users, what components do we need? What would the system need to do? Like, what would be the first 3 or 4 requirements that you need to cater to? Guesses, thoughts, proposals? When you're building machine learning on the web and machine learning as a service, that is, your user should be able to do machine learning. You can always do machine learning yourself. You're a developer after all. But if you want your users to be able to do machine learning, what should you cater to first? What are the different things you'll need? Yes? Yes, which is what we're building, more or less. You need a web server, exactly. So let us say we need a web server, yes?
You need a compiler running so that that can interpret whatever code is written, run it.
Assume it's, yeah, assume the compiler. I guess, yeah, all components of this apps will take care of their own code. I mean, and again, you are not expecting users to literally write code. If they do, it will be Python code, let's assume, or it's at least going to be something that, you know, the individual components can take care of. It's machine learning as a service. So what would you need? Sources of data, exactly. And in what kind of sources can the data come?
Can be URL, it can be CSV files, text files.
URLs, yes, files, and JSON again, sure. API, JSON, URLs, let's club them together, fine. Files, databases, exactly. So data is going to be APIs, files, and databases, right? What else? That takes care of our data part. What else is needed? You need the ML itself. You need models, right? Which, you know, you can expose a certain list of models to the user and say that, okay, these are the models we support right now. Would you like to go and train one or something like that, right? So yeah, we need this, by the way, is a very generic block right now. I mean, in the next hour or so, we are going to deal with scikit-learn, but it can be anything. It doesn't have to be just that. These are algorithms. These are implementations. Like, you know, if users are expected to build something like a spam classifier and you say that, okay, I do not support naive-based classification, that won't work. What else is needed? Yeah. Data visualization. Correct. So yeah, inference on the models is required and that has to pass through the server. Yes. Like, people need to be able to get predictions out. One other thing that you need is perhaps figuring out how to manage your users, because there'll be different kinds of users. There'll be there's always this one user called admin, right? Admin is somebody who can do absolutely anything with your app. They can like completely nuke it, or they're basically the god. Admin can do anything, right? So there is, forgive my poor drawing. Okay, that's a very fat admin, but okay. Then there could be users who are data scientists who actually train the models, right? So let's say that, okay, I'll just stick with stick figures. And then there are simply users who are just drawing inferences, right? They are not allowed to train the models perhaps, but they are allowed to draw inferences. They are allowed to use the models for predictions, right? So there's going to be these multiple categories of users. Why is it important to categorize them? Exactly. Access is not uniform across. What I let an admin do is not something that I can let the other people do. An admin can do anything. A data scientist can create models. Maybe they can CRUD models, sure. They can train models, and users can, well, they can do two things: draw inferences and give feedback. Because typically what happens in web applications that do ML is that you need to allow users to put in some sort of a feedback loop. For example, in Gmail, there has to be a way to tell the spam classifier that a given email is not spam, or a given email is spam. When you do that, when you mark something as spam or you take something out of the spam folder, something has to go back to the server so that it tweaks itself, right? The model changes. So these are users and they are also annotators, right? So we have our users, we have the data, and we have the models. And the server is coordinating this whole thing, right? Does that make sense? So here, again, we have to follow the flow of data, essentially. That's a good refactoring strategy. So let's begin with that. I think what we're going to do is create a simple web server which simply lets you build models, okay? What's the simplest model that we can think of? Stochastic regression is fine. Based on what? Like okay, let's be very, very specific and say I just want to do iris data, right? I just want to train it based on the iris data set. So the first thing I'm going to do is create that model, right? Again, I'm not creating the model right now through the web app. I'm just going to have a static model. Let's assume somebody's given me one, okay? So, come on. Anybody wants to take a guess at what went wrong over there? Well, how many of you have seen this kind of code before? I think MLP people certainly must have seen it, but by any chance have the others seen what this is? Correct, yeah. Oh. Whoa. Didn't I say as frame? Ah, yes, correct. See, I'm forgetting all my MLP stuff after what to say. Perfect. Wise. Yeah. Is this clear what this means? Okay, is there somebody to whom this is not clear? What are we doing here? Who is totally lost? Okay, so what we are doing is there is this data set called the Fisher Iris data set. You must have heard Ronald, have you heard the name of Ronald Fisher? Father of statistics. He collected this data set as an example of demonstrating classification problems. So what he did was he collected 150 samples of the iris flower. And for each flower, he measured 4 parameters. So the sepal is basically a type of a flower body, well, part of a flower's body. This thing is called a sepal, right? So the pod inside which the flower grows, and once it grows out, like the pod shrinks, right? The flower is bigger, obviously. So that is the sepal, and you know what a petal is, right? So let's close this off. For each of those 150 flowers, he calculated these 5 things: the sepal length, the sepal width, the petal length, and the petal width, okay? And these 150 samples of the iris flower were categorized into 3 classes. So there are 3 species of the iris flower from which he drew these samples. And those 3 species are in our target variable. So the task here is that given these 4 parameters, if I were to give you a flower out of random and you were to measure these parameters, you take a flower, you measure its sepal length, sepal width, petal width, can you tell me which kind of iris it is? Right? There are 3 types of irises here. They are called versicolor, virginica, and setosa, right? So out of those 3, which one is it? And of course, we are not using those names. We are just using integer labels like 0, 1, 2, right? And we are going to fit a logistic regression on it. Logistic regression is one of the simplest classification algorithms there is. It does a very simple job of classifying data that is linearly separable. When you do MLT and all, you will figure out what that really means, okay? Okay, one thing that I probably should be doing, and it will soon become clear why I am doing this, I am going to change the name of these columns. I am just going to call them ABCD. Just for convenience, because sepal space, lens space, bracket, CM, it will become tough to type. And again, remember that we are supposed to take this to the web, which means these are the kind of things people will type in their URLs. And how do you encode a URL which has a space in it? You add some %20 character or something like that, or a plus, right? We don't want to do all of that, so we're just going to call these 4 parameters ABCD, right?
Information about prototyping while you're talking about the coding part.
Yeah.
So that the prototyping is the main concept you're trying to push to the coding.
Yeah, yeah. We're coming to that. In fact, good point. Let me not get distracted by the iris data set. So I'm just going to create some model. And suffice it to say that it's simply something that knows how to identify iris flowers, okay, given these 4 parameters. Okay. And what we now do is the model is created, it's fitted, it's trained. We just have to save it to disk for it to be used by the server, right? So we are creating something here. And this is where things get tricky. When a model is saved, is it not data? It is kind of data, because these will be specific to user. It is not training data, but it's still data. You have to manage it for certain users, right? Joblib is a library that is used to save models and load models from disk. So right now the model is just in my Python session. I have to save it and then I'll have to load it back, right? And I can just do LR. Let me quickly check how this is done. Value and file name. So I'll do LR model.pickle. Done. So we have a model file with me. Okay. Now let's start creating our server. We are going to use a Tornado implementation called Gramex. So think of it just exactly like Flask. How many of you are familiar with Flask or Django or any other web service? Okay. So think of it exactly like Flask. These are web frameworks in Python, essentially. What that means is that, when you did intro to Python, you were doing things which are local to your computer. Your data is present there and you're doing all your computation there. But the thing is that things happen over the web, usually. So if you were to build a server, the way to do that in Python is using these libraries. These are called web frameworks. So they can help you receive requests over the internet and serve responses over the internet and so on, which is what we are going to do. And the entry point, the configuration essentially, is a single configuration file called gramex.yaml. So what happens is you start a section called URL. This is where all your URLs are going to be. We'll need different URLs to interact with the web app, right? So there'll be a /login or a /logout, /train model or something like that, right? So this is where we list the URLs, and there will be different pieces of code that we call based on which URL it is. Right now we have a model. What do we want to do with it? We want to draw predictions. Something as simple as that, right? So I'm going to create a URL called simply predict iris. Okay? And I need to give it a pattern because, typically the way to create URL is to have some sort of a text pattern, right? So my pattern is going to be URL/predict. That $YAML URL is a special variable in Gramix, which simply means localhost :8000 or whatever it is that your base name is, right? So for example, when you're building an app, you don't know where it's going to run eventually. It could be running on facebook.com, it could be running on google.com, it could be running anywhere. In fact, those of you who have done Replit, you know that the URL change over time. But there is something, there's something called the domain and the host name, which is the base of your URL, and you can only control things that are outside it. You can't control the URL itself, yes.
So I've never really developed a web app.
Ah.
I've done a Mac to,
Yeah, you have developed web apps then.
yeah, but not the way you're explaining in terms of exposing them to the internet. So,
Okay.
so when I look at rapid prototyping, just trying to understand and summarize what I've understood so far. So for me to develop a prototype, I need a server. I need a way to allow access to the server.
Yes.
My server will have certain things like data repository, model repository,
Yes.
user access control, and so on.
Yes.
Right? So that is that's English. I mean, I'm talking in English.
Okay, carry on.
Now you're explaining to me how I can allow access to my server in a structured manner by providing a URL. So let's say I talk about Gmail, for example. So gmail.com and then
Yeah.
box, etc. So you are helping me understand how I can write, how can I expose what I'm doing on my server to users by
Yeah.
using this URL construct.
Yep. Which is why predict is a very specifically picked name. It's a verb. And one of the things that we know, you'll eventually figure out about RESTful APIs is that HTTP requests themselves are verbs. Get, put, post, delete. Couple of them are not. There's one called head and the other called options, which we rarely use. So you're asking the server to do something for you. Right? Here we are asking the server to predict stuff for us. Now it could be gmail.com/predict, it could be facebook.com/predict, I don't know. Go ahead, sorry.
So I have a server. Now I have a URL construct using which users can access my server.
Yes.
Because the URL is typed doesn't mean that it will get access to the server.
No.
There's still a
There's still a layer.
connection that needs to happen
Yes.
between the URL and the server.
Yes.
Which is through a framework that you just talked about.
Which is this, that pattern keyword takes care of it.
No, what's the name of the framework?
Gramix.
Gramix.
Yeah.
So there's a framework called Gramix which allows users to interact with the server using a specific pattern.
Yes.
And Gramix
Just like we write the app routes in Flask. Same thing is happening here. So typically, no, that doesn't matter. But the point is that a single server can have multiple endpoints, multiple URLs. So and each URL calls a different functionality in the backend. So depending on which URL it is, how do you map it to a certain Python function? That is the text pattern, right? So for example, if I were to do something like train iris, I would write a different pattern. I'd probably say.
So basically, Gramix allows you these capabilities to define the URLs and define the functionality that the URLs will call.
Yes,
So
exactly.
you have the server, you have Gramix, then you have the URL. Those are what are your ways.
Gramix takes care of the URLs themselves, yes.
Server side, you have data, machine learning models, and user control.
Precisely.
That's what you explained so
That's it, yep. And again, we are just going to use something called a request handler because a request comes, it has to be handled. And the objects that are used to handle these requests are called request handlers.
when someone types something, this is how it will be handled.
This is how it will be handled. So Gramix contains a bunch of different request handlers to begin with. The simplest is function handler. It turns a Python function into a request handler. That's all it does. There are other things like login handler or logout handler, which actually logs and deletes the cookies and things like that, right? So there are a bunch of these. There is a Facebook auth handler, for example. There is a Google auth handler, which when you click that URL, you will be redirected to sign in through Google. So these are all different tasks that can be, used in specific request handler. We are going to keep things very simple and say just use a function handler, nothing fancy. Just let a Python function do my request handling, right? And then, of course, we have to specify which function to call. So I add some keyword arguments, the most critical of them being simply function. Which function to call for this pattern, right? And I haven't written any Python code yet. So I'm just going to do something like, mls.predict. How many of you understand the dotted path syntax in Python? So anything that you import has a path, right? Not the path in the sense of path of a file or something. Actually, it's very similar to that. Literally, in the organization of your Python module, the path of that file becomes the dotted path above, except instead of slashes, you have dots. So for example, from os.path, import something, base name. So it's os.path.base name, right? And this is exactly that. What this means is that it will expect that there be a module called MLS, right? And inside that, there should be something called predict, ideally a function. And we haven't created that file yet, so let us do that. Fine. The function at least exists. I mean, we've started beginning to, oh. Is that visible, the first line? It's a little dark, right? How about that? It's fine. And it's going to take simply instance of the handler. This is the request handler that is passed to the function. And now, within that function, I can manipulate that request handler to do anything I like, right? What is the job of this function? To predict stuff, right? In order to predict something out of a model, what do I need? I need data, right? And what is the data that the model is expecting? ABCD, exactly. So, well, first of all, I have to load the model, right? Because in this particular Python module, the model, right now my model.pkl is there, but I haven't told it anything about how to grab it or load it. So again, just like if you remember, we had a joblib dump. We have a joblib load also, right? So from or let me be a, oops. And then I can do something like model.predict of something, right? Now what that something is, it's going to be specific values for ABCD, which are going to come from my handler, right? And the way to do that is simply handler.args, or specifically handler.args is going to give me a dictionary of all the key value pairs that are there in my URL. So A becomes a key and all the values that I've given for A will be 1, 2, 3 or whatever. So it will be a dictionary with strings as keys and which are my sort of column names or something like that, or URL query parameters. And values are going to be the values that the user actually puts in, right? And in order to deal with that very specifically, we use pandas data frames earlier. Let me also use that. So what I'm going to do is, let's just say data, like pd.data frame. Come on. Of course, the model has to return something, right? What? Flake it not found, I don't care, okay. Fine. Is this fine? Now let us start the server itself. What are you saying? I just put in a gramex.yaml. Oh, it's there in my buffer, but I never wrote that file. It was just keeping there open. There it is. Okay. So you see now it says gramex blah 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 listening on. This typically is the alias for the localhost, which means it's my own computer. Port 9988. That's the default port. You can change it, right? This is what is that YAML URL. So next to this, I can open the /predict, right? And let's try that. So I go to localhost colon 9988 / predict. But what's wrong with this? No arguments. Exactly, it's going to crash. It's going to complain about something. Application error. Obviously, this application made a mistake. The one other good thing about Gramex is that you can see the Python traceback right here. Let's see. At least one array or D type is required, right? But is the error you see is coming from, by the way, reading Python errors is an art. It's a developed taste. But the sooner you get familiar with that, the better it is. And there is an anatomy to this. Like the errors are laid out in a very, very specific fashion. This line, the last line that you see, is what went wrong. This particular line right above it is the line that failed, the actual source code that failed. This, by the way, is supposed to be English. This is supposed to be Python. And the file above it is the file where that line exists, right? So there is some file called sklearn utils validation, and that had a line 882, which was this, which failed, right? So what is it saying? At least one array or D type is required, correct? So can I do this? A equal to 0 and B equal to 0 and C equal to 0 and D equal to, yeah, 0. This is no flower really. Like it's just some random stuff. But what do I get? This is whatever, I mean, it's either Setosa, versicolor, Virginica, whatever is indicated by the value 0. What else can I do? Let's get some real, which is wrong by the way, obviously. There is, if your pitil length, width, sepal length and blah, blah, blah are all 0, you're not holding a flower at all. So let's put in something real. Can I do that like, okay, no, not that. Okay, not that iris either. Yeah, but I don't have the data frame lying around anywhere. I could actually open it up. Yeah, why not? Do we have, okay, my screen just froze, I'm sorry. Okay, slowly. So these people are not likely to have a sample here. So anyway, correct. I can always do x dot head of 1. And in order to see that, it's 5.1, 3.5, 1.4 and 0.2. Okay. 5, 3, 1 and well, let's keep it 0.2. It is 0 because that was the corresponding y. Let me take a tail value and see if it works. Oh, and by the way, you can see the logs here. So I expected a GET request on my model at the /predict endpoint. It was served in 9.3 milliseconds, and predict iris is the corresponding handler that was called. Okay. So my tail value is 5.9, 3.0, 5.1, 1.8. So 6352. Okay. Sorry. It's a tail, which means I can also look at y dot tail. It's 2. So what was it again? Sorry, 6352. So let's try that. I'm going to say 6352. That works. We have, and of course, by the way, the good thing about URL parameters is you can repeat them. So for example, what was the earlier one? Well, we knew that 0000, it's saying is 0, the output is 0. I can always repeat A. Can I say A0 and B0 and C0 and D0? What would this do? Any guesses? Yes, but what do the, I've used A, B, C, D twice. These are two samples. I want to get predictions for two samples. The first ABCD is the first iris, the second ABCD is the second iris, right? That makes sense? By the way, there is a slight problem here. You see that 2, 0 being, you see how it's appearing? It's appearing like as if it's in Times New Roman, right? The font. That tells me that it's appearing as HTML. So, and I don't want really HTML. This has nothing to do with front end. We can do a quick thing to fix that. What I can do is handler.set argument, set header. So there are these really useful things called HTTP headers, which tell the client what to expect, more or less. There is something called the content type header, right? And if the content type header is JSON, the client or the browser will start expecting a JSON response. If the content type is a download, then it will sort of hint to the browser that you're supposed to prompt the user to save a file, right? Tornado does. Gramex is a wrapper on top of Tornado, yes. So which is what I'm doing. I can do a handler.set header. And what's the header I want to set? I want to set a header content type, and I'm going to call it application/JSON. And when I go and refresh this, did that work? Oh, it's a 304. So, by the way, an HTTP 304 means a cached response. It's not creating a new response again. It's just giving me back the old response, which is why I made a change to my file, but it did not reflect. Can I do a hard refresh? I did that. I did a Control-Shift-R, which means it forces the backend to send a new response. So now you see, now it's 200, right? And I have a browser extension which automatically parses JSON data, which it did. So earlier it was appearing as text, now it's appearing as proper JSON data.
Can you just summarize the flow again in your code? So we started with the server thing.
Correct, yeah.
You went to the right.
So what we have is, this is a configuration file that it's essentially a DSL. It's a domain-specific language which lets me specify my URL patterns and my Python logic and put them together, right? And I can then write the Python code. The file is going to obey this code and react to requests accordingly, right? What is happening in the code is just prediction. That's another story. I could do whatever I like, right? But by the way, this, I don't really need this because thankfully, I can just do it here. Yeah. And there is a good reason for this. The more code you move away from Python towards simpler languages like JSON or YAML, the better it is. Because this is something that's easier for me to review. This is something.
The output that is coming on the browser is the JSON output.
It's a JSON output. Earlier it was text.
And that's
Plain
what the
text.
JSON output looks like.
Yeah.
You didn't do anything special there.
I mean, I had a browser plugin that parses JSON text. Now, here's the thing. If I wanted to query the entire iris dataset, or let's say there are 150 samples, there's something called cross-validation which we do in machine learning, right? What we do is we keep some data untouched. We don't train the model on that data. And we train it on, let's say, 80% of the data, and the 20% is just supposed to sort of help us test whether the model is learning something or not. Because if I just put all of my data in the model, and I keep testing from the same data set, the samples that the model has seen, how do I know I'm not secretly saving it in a DB? We get this kind of questions from clients sometimes. So, but a very fair question too, of course. Like if I'm just memorizing things, it's not learning, right? So what we want to do is get predictions in bulk. Can I keep doing this if I wanted if I wanted prediction for 30 samples, what would I do? Here I can do 2. Very good, yes. Upload data, right? Or, yes? We could, but that's actually very risky. Get requests, especially URLs cannot be allowed to grow too long. Because, of course, it's controlled by the server also. Now, my server right now doesn't have any restrictions, but typically the Apache web server or Nginx, these are the 2 things that are used most. They have a limit on how long your URLs can get. And let's say for every sample I'm adding A, B, C, D, 3 into 4, that's 12, plus the ampersands in between makes 15. 15 characters for one sample. For 30 characters, going to 440 characters, 450 characters. That's too long. I cannot allow that because beyond a point, you see my logs. What happened? Yeah, my logs are pretty long as it is. So if I want to do auditing on everything, people will be able to send these files and choke me up, right? My server might crash. People can put in practically malicious stuff also through the URLs. So if you want to send me a lot of data, don't do that through the URL. Upload a file, right? That is another, upload a file or send JSON data through a post request, right? So now we have done get, now we need to cater to what is called a post request. Post request means you're posting data, right? So let's do that.
Is there some way for me as a user to know that I have these options and I can do these?
Yes. As a user, as in? Good point. No, unfortunately, unless somebody is going to have to document it for you.
There's nothing here which
There's nothing here. Yeah. So what there's something called Fast API, which some of you must have heard of. So it's a very new and well, not really very new, but it's the best web server out there, and Gramex gradually is going to migrate from Tornado to Fast API. Fast API has this beautiful property that it is self-documenting. I just write a file like this, and I'm just going to then add something like a new URL called something like this, or docs or something. It will automatically generate documentation. For that, of course, my Python code has to be documented as well. Like it has to pick up the docs from somewhere. So I have to say here that, okay, this accepts get and put requests and stuff like that. So that is still there. It's not ChatGPT that will read the code and generate stuff. But documentation becomes really easy with Fast API. There's something called Swagger, which they use. Swagger UI is a framework which goes through your code and automatically generates a UI for those APIs, right? All right, so what we need to do now is post data. Oops, again. Let's do that. So what I'm going to do is my X is the data here. Again, let me just move this a bit. Again, x.columns, I'll just make them ABCD for brevity. Again, because that now you realize that just with ABCD, I'm getting long URLs. If I actually left the columns themselves, they would become even longer, right? So yeah, there it is. What I'm going to do is randomly sample 10 of these, right? And what do I store it as? CSV? This is fine. The dot sample is going to pick 10 samples at random. and dot to CSV is going to, it will be a new data frame, right? That new data frame is going to push to a CSV file. Index equal to false means that these values, the row numbers, I don't need them, right? So don't write the index of it as well. That is done, and can I take a look at test.csv? That's right, CSV file is done. Now the question is, how do I put a file through a request? I can do it through request, but let's try to do it through curl. And again, I am terrible at command line tools. I barely pass system commands. So I'm going to ask ChatGPT to write a curl request for me to submit a CSV file. It's going to take forever.
Will the URL, the code you wrote in your YAML file, will that be able to handle curls, etc.?
No, curl is just a client, so it doesn't matter. Curl is just a way of sending requests and receiving responses, that's all. But you're right. Right now, it's expecting everything to be in handler.args, which means the URL. So we will have to go and make changes to the server. Okay. Well, let me give it a shot. So can I do curl minus x post minus f? Hey, I can always read curl documentation, right? It's relying on ChatGPT for everything is bad. File, 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 file. How do I submit a file? What does we see? Minus D data. Okay, it worked. You know how? I got a 403 post from this. 403 means forbidden, it's not allowed, because we haven't told our server that it's supposed to expect post responses also. Again, quickly let us make that change and say that, yeah, go ahead, please accept post as well. And there is a quick way of doing that over here. A get is allowed, obviously, that's the default. Post is also allowed. And because post means that users are putting data in your applications, they typically need to be authenticated. Here, there's no authentication, so it's simply saying I'm not allowing anything. I'm going to flag here, which says that don't validate the user. Don't look at the XSRF cookies. XSRF cookies are what tell the server who you are, right? So don't use them. I'm going to do that again, and I'm going to run curl again. Oops, sorry. Sorry? So I just realized that that was wrong, because by default, function handler accepts all sorts. Yeah. If I had to restrict them, I would have to use that, right? There it is. You see that this worked. My screen keeps freezing up. You see what happened is I sent this request and I'm getting some sort of HTML output. You remember that error that we saw earlier? That was, it was a web page and there was a button called show traceback, right? That is the page I'm getting, and if I were to actually look at this properly as soon as my screen unfreezes, what is it saying? Let's take a look. So this is my traceback. The feature names should match those that were passed during fit. So it clearly can't read the data. Now I need to go back and change it, right? So I have to rewrite my handler. right? Model, of course, I'm going to need no matter what, whether it is a get or a post. And what I'll do is if handler dot request dot method is get, then do this. Elif handler dot request dot method is post, then I'll assume that you're posting data. You're sending a file, right? Then read the file. And the way to do that is data is pd dot data frame of, thank you. Of course, the file is a CSV file, right? Which means I'll have to do pd dot read CSV perhaps. No, sorry, handler dot request dot body. Of course, there is a problem here because read CSV expects a path on disk, whereas I'm just giving it something arbitrary. So this may not work. Let me see what the right way to do this is. What I could do is from bytes, well, let me actually just run this and see what works. And anyway, the difference between these two is simply how you read data. The model.predict of data remains the same, right? So let's go ahead and do that curl thing again. Oops, sorry. Something else went. Exactly what I said. Expected the file path name or file like object and got bytes. So it's not able to read the bytes of that file. So we'll have to first, what happened is that the CSV file, it read the raw bytes in that file and sent it. But read CSV needs, or data frame, basically it needs, read CSV needs a path or a file like object in Python. So which we don't have. What we'll do is we'll create one. I'll say f object is bytes IO of handler.request.body. Does that make sense? I think so. And let us take a look. Feature names unseen at fit time. Is it? Oh, interesting. You see, feature name seen at fit time yet now missing. So it's probably reading something the wrong way.
Just go up and see a dump. Yeah, just see a dump. Where's the dump of the?
Of the file?
No, in this there was a dump of the code, the bytes that were read. So after D, it was going straight to 6.9. No comma after D.
So feature name should match those, sure, which simply means that it's not getting ABCD properly. So what's the problem?
Getting ABC, comma D 6.9. The new line.
No, that's not the issue here. Let me just quickly take a look because let me see if this data is correct. I can quickly, what I'll do is I'll add a tracer here. Oh, no module named IPDP, no problem. So what I can do is just interrupt the server quickly, install the IPython debugger. I know we are barely scratching the surface of what I really intended to cover, but since, looks like we won't be able to have a very interactive workshop. So I wanted sort of you to code along with me and there were notebooks and all lying around. But since only few of you have it, unfortunately, this is, you're going to be prompting me for another 30 minutes, I guess. Is this making sense? Any questions so far? About what we are doing, how we are proceeding with the prototyping part?
I found it very interesting. I've never coded end to end. So even a small app, I
Oh, yeah, yeah, absolutely. Okay, so IPDB is installed. Oh no, my server I have to start, of course, because I interrupted it to install the dependency. Now it's up again, and there we go. And there it is, now it's stuck. Can I look at my data? In fact, it looks like my data is not getting read properly. It's not reading it as CSV. Something is going wrong.
It's not taking new lines.
Huh?
So that means the data frame that you're creating from there when it is doing a read CSV, it is reading it as a single line instead of multiple lines. The entire data frame is being read as a single line.
Correct. So if I say handler.request.body, that's where my trouble starts because that's the source. Of course, it's a binary string. It's not. You're right. Yeah, it's not taking this.
So you can see 1.54.8
Hmm. Hmm.
and 0.46.3, which means it's a single line, a single string.
Which means that I should not be sending it as a binary encoded data stream at all. I should be sending it as straight up the file it is. It's like actually submitting a file. That's what I should be doing. Which means that I do not need handler.request.body. So let's remove this and all of that. And it's minus D. Can I have a
So there were options in curl, man curl, if you look how to
correct?
send a file. It gets out to minus minus 5.
No, it says file is not found. So, okay, data raw, data URL encode, F form. Okay. Well, okay, chat GPT is here. I guess, right? Curl post request, which come on. Let's continue looking here. It's minus F is form, and there we go. It's now instead of uploading binary data, I'm submitting a form. And typically you see in HTML when you do front end, you have this input type file, right? And when you click on it, it opens up a Windows Explorer or something like that. We are mimicking the same thing over here. Let's say data equal to test.csv. Okay. Obviously it failed because we haven't accounted for it. And again my screen is frozen. I wonder why this keeps happening. Any questions so far? While we wait for this to unfreeze. Yes. Gramix is library. It's almost like the whole thing rebooted. What just happened? It's acting like Windows, randomly just doing updates and rebooting or something. And I hope this is, oh boy. Thank God, my Tmux session is still up. Great. So the issue here it is error tokenizing data. Yeah, makes sense. It means my file is, now I'll have to actually do something about this. So I'll have something like handler dot request dot files, and the name of the file that I gave it was data. So what this means is that I'm going to have a field in my form called data, and the value of that field is a file, right? So can I have data over here? Yes, I guess so. And again, let me put in the tracer just so that we just move this away so that this works. Do I need to restart something? Oh, unexpected indent. Ah, of course. Why? Where? Ah, okay. This needs to be indented properly. And again, it's stuck, which means that it's probably going to come up here somewhere. Is it? Yes, it should. Yeah, there it is. So I just press N and it will say OK. So handler dot request dot files is a dictionary finally, and now I have the body of it presented properly with new line characters. Now I can do a read CSV on this. So can I do this PD dot read CSV of handler dot request dot files of data? It's only one file, body. So it's basically my file is again going to be the same thing, and it's files, because a request can have multiple files. And again, I need to create a binary buffer object so that the string actually behaves like a file instead of a string which is in memory. So from IO import bytes IO. Say f object is bytes IO of x of 0. There's the first file, body, right? That should work. Let me interrupt that, send the request again. Something obviously stopped here. Let me go ahead and interrupt this. Oh, did I? Acha, set trace is still on. So let's do that. There it is. My data is ready. So I continue, and it did a 200 post and it returned a list, a JSON list, right? Which are essentially 10 randomly picked samples. You can see 0, 1, 2, and all that. So this is how I can get predictions in bulk, right? Now let's take a pause and see a little more in detail what we have done. Of course, first thing is to remove that set trace. Next item of refactoring. Can you see something very obviously wrong with this code? Big glaring mistake. Sorry? Well, it's not really technically, logically a mistake. It's just a terrible practice that I've used, which will be a nightmare in production. Not really. I mean, that standard library, so importing it is fast, but nevertheless, the only reason to leave imports in the middle of functions is if that thing is going to be used exactly there and nowhere else in the code, which is true in this case, but who cares? So, what just got opened up for no reason? Yeah. What's the problem with the logic here? Look at every line of this function and try to see where the problem is. Here's a hint. Every time I do a get or a post, this function will get called. Sorry? Yeah. Fair enough. We are not allowing delete. So even if, If handler.request.method is get or post, it's going to do something. Good point. If there is an else, it will do nothing and data will be absent because data is being created within those two things. So the way to handle this is else, which means any other method, which is not get or post, we raise an HTTP error. You must have seen HTTP errors like 404, not found, right? Typically, 2xx, anything in 200s is good. Everything is fine. Anything in 3xx means good, but I'm not going to do anything about it. The server is saying that, okay, noted, but like redirects, for example. I'm not doing anything special. I'm just going to return a cached response or redirect you somewhere. 4xx means you're doing something wrong. 5xx means I am doing something wrong. That is the server. So 2xx, again to reiterate, 2xx is everything is fine. 3xx means everything is fine, but I am being lazy. 4xx means you messed up. 5xx is I messed up. So what kind of error should we raise here? You did something wrong. And typically the way to do that is called bad request, simply, or unsupported request. It's, I think, 400. Let's quickly check that. You remember 403, unauthenticated, 403 is forbidden, which means that you're not allowed to do this. 401 means unauthorized, that we don't know who you are. I said HTTP, bad request error. Okay. We can just do that, right? And of course, 400, like, because these numbers are difficult to remember, Gramex includes these aliases which are variables. So I can do something like from gramex.http import bad request. Let's do bad request. And when this happens, I don't care about whether it will reach this line or not, because it won't at all. The request will just crash over there. What else is wrong? By the way, one other way to fix this is put methods there and say get post only. Now I'm writing 3 lines less, right? Like I would be writing 3 lines less if I did that.
So I think the main message in rapid prototyping is that there are tools and libraries available.
Precisely.
Cut your
Exactly. If I'm writing YAML code, or well, YAML is not even code, it's basically text. It's structured markdown kind of thing, right?
So I guess so if I was building an application from scratch
Hmm.
using a server, it will let's say take me 10 days, but using these kind of libraries and YAML,
Precisely the point, yeah.
I can bring it down to 95, I mean instead of 10 days I can bring it down to let's say 3 or 4 hours
Correct.
and do rapid prototyping, which
Yeah.
is what you are.
So if I had put in one line there which says methods are only allowed in get and post, I can save 3 lines here, 3 lines of Python code. I don't need a return, I don't need a raise. Gramex will take care of it. You are actually sending something that is not allowed. And in fact, let us do exactly that. Why beat around the bush? So, which means not required. In fact, even all of this, not required. I can just do else, right? Because if it is not get, it has to be post, otherwise it's going to have crashed anyway, right? In fact, it will crash right in the beginning, it won't even enter the function. So I get to save computation, which means again I can save this one line of import I don't need, right? What else is wrong with this? Okay, notice that I'm loading the model every time, which is terrible. If it's a tiny, stupid logistic regression model, which is fine, I can quickly load it. What if it was an LLM, or what if it was, forget LLMs, what if it was something like VGG19 or a transformer or something like that? That would become ridiculously hard. So how do you fix this? I want to load a model ideally only once, Or I want to, let's say the smart way of doing that is, if the file has been modified recently, then I want to reload it. Because remember, users, admins, they'll keep on putting stuff while other people are drawing inferences. So my users will be like, please give me a prediction, please give me a prediction, and these people is like, we can't ask for downtime always, right? Typically we do, we'll say that users, please stop drawing inferences for the model from 12 p.m. to 2 p.m. today, we are going to update our models. In which time they update it and everything is fine. But then if we do that, how do you do online learning? Because in Gmail or something, I mark something as spam or ham, it quickly goes and updates itself. Nobody is stopping servers there. So how would you handle this situation?
You can convert it to a library or create
How?
a way in which your model gets fitted in some place where you can import. That way that you can go to.
Sure, but what's the strategy? Like, I'm not talking about the implementation. Logically, how would you decide when to load a model and when to avoid loading it? Cache it, yes. So there is something called least recently used cache, which is, it's basically this in-memory store of objects in Python. And the least recently used thing is popped out first when the cache runs out of space, right? But the question is, you cache it based on what?
On the get request we can cache it, on the post request we can reload it.
What if somebody sends a post first?
Then we have to reload it.
We don't really. Doesn't matter what, see again, the model loading is outside get and post. We can cache it, see when we cache things you need not only the object to be cached, but the key against which you are caching it. And if that key changes, it means it's a different thing, it's not, the simplest cache in the world is a Python dictionary, right? Sorry? How? But that will corrupt my file, right? It won't be a scikit-learn pickle model anymore. If I go around messing with bits, that is. The simple thing that we typically do is something called mtime. System commands who's finished? Last modified time of a file. You cache things simply based on, and reading an entire file is expensive. Getting the mtime of a file is one of the cheapest things, at least in Unix, right? Is there actually an mtime or no? Actually, I can just do ls minus lt perhaps, right? This file was, okay, tell me if this is supposed to be created or modified. It's modified, right? Like, or, okay, 1130 is when lm has changed. I'm going to go and add a new line character and I do this again. It's modified, perfect. So what I do is, I look for the last time a file was modified. If it's newer, I reload the file. If it's not, I don't reload it. I use the cached file. And the way to do that again in Gramex is simply from Gramex import cache. And model is cache.open and give it the path. This works for files, by the way. For databases, no luck, unfortunately. For the database administrators, have to give you a separate metadata which tells you that, okay, these rows have been modified and these tables have been modified. For files, this works. I'm going to cache open one particular file based on this. By default uses the last modified time, but I haven't told it how to open that file. I've only given it the file path. If it was a CSV, I would have to say use pandas.read CSV. It's a pickle. I'll have to tell it that there's something called a callback, I think. Yeah. Callback. And callback is a function which Gramex will use to open that file. And that in our case is just load, which was the joblib load, right? Now you see the file is not going to be cached again. And I think we should be able to see some performance improvements also based on this. Where is it that I got my last 200 FS events, blah, blah, blah. Okay, that's fine, but yeah. Here, right? I think there was a, there it is. Okay, this is a bad comparison. You see 12,763.93 milliseconds. Any idea why it took so long? So this is how many seconds? It's, yeah, 12 seconds. Why would it take 12 seconds? Because I had a debugger tracer in it. We were messing around for 12 seconds before I allowed it to continue. Nothing to do with the app. But anyhow, since this is now done, and I can send another curl request now. You see, that was, again, not that I expect any great changes, but it's only 16 milliseconds now. So the file is cached, and it won't be read again. But let's see if we can hack this around.
One single sample had taken 9 milliseconds initially.
Really?
Now you're taking 10 samples from a file and it is happening in 16 milliseconds.
Very good point. Why do you think that is happening?
Because the entire thing was being read immediately, so there's only one IO.
Because I'm still within the limits of my RAM, and scikit-learn is optimized to deal with numpy arrays very quickly. If I create a single row, which is a numpy array, sure, it takes k times, but if I do, let's say it takes k seconds. If I do 10 rows, it won't take 10k seconds. It will be less because all of it's vectorization. Like those of you who do MLP and MLT later realize that there is something in NumPy called vectorization. There is some element of parallel processing can happen. So it's not linear time.
And all this is critical because every millisecond matters.
Every millisecond matters, especially when you are Gmail or AWS SageMaker or something like that. Let's do a little bit of a hack. This was 16.25 milliseconds. What I'm going to do is cp my model.pickle to model.pickle2, and then I'm going to cp it back. So now my modified time has changed. Although it's the same model, my file is a new file. I have a file called model.pickle2. I'm going to make it model.pickle. I have essentially just swapped the file, right? But now my last modified time should change. Does it change? Let's see. You see, the original modified time for this was 10:39. Yeah, now it's 11:38. Now my hypothesis is that it should take longer than 16 milliseconds. So let's take a look. It took less, in fact. It took only 7.64 milliseconds. I don't know what's happening here. Why is it faster? Why would it be faster? No reason. Of course, it's a really tiny model, so we would have had to experiment with many other types of models. Anyhow, so note that these are only, we have only covered, and we are kind of getting out of time, but we have only covered the inference part. There's a training part also. So how would you expose scikit-learn to the user? Like when we started with an IPython interactive session, and we created something in scikit-learn, we dumped it as a model.pkl. When you start a fresh slate, none of those things are existing. I want users to create models. So how will a user say to my server, make a logistic regression model and train it on Iris CSV? How would you do that?
Maybe an interface that gives a drop down, say,
No UI. No UI. Okay, well, when you say drop down, that's interesting because I have to first of all tell my user what is available. Without that, I can't do anything. Let's assume I say that everything within scikit-learn is available to you. And the user knows scikit-learn, it's just that they don't want to write Python code. One. Sorry?
Script that can automate the process. I mean, they choose, like, you can have a drop-down
Exactly. But a way to do that is there's another very interesting library called PyDoc. And what PyDoc does is when you have a dotted path to a Python file, it will actually locate that file or that class. So my path is sklearn.tree.decision tree. Now you see, it's a string. It's not really the decision tree object. And when my user is interacting with their UI, they are going to be sending me text. There is no such thing like I cannot send a scikit-learn decision tree from front end to a back end, right, over HTTP. They're going to be sending that string. So I could have like a drop down where this is one string. In the back end, interestingly, what I can do is, so there are two things. There is this path, and then based on this, what I have to do is import sklearn.tree.decision tree or something like that, right? I'm not even sure if that's possible, but how do I do this? The user is going to send us strings because that's all the user has access to. Or in fact, it's worse. That string has to be mutilated. Oops, it's decision tree, let's say classifier. Sorry, it's not decision tree, it's decision tree regressor or decision tree classifier. Okay, then it has to be a stratified import. Yes. What the user gives me is this. The user gives me a string and assume that it's decision tree classifier. And what I want is this Python object based on that. How do I do that? Short answer is you can't. So there are libraries that do this for you. There's something called PyDoc. So I'll say import PyDoc. And PyDoc has something called locate. So what it does is that locate an object from a name or a dotted path, importing as necessary. It will figure out how to import that automatically. So pydoc.locate of sklearn.tree.decision tree classifier is there. You see? And I can just do this. This is a class which is now available to me, and I can use it in exactly the same way that I would use an imported decision tree. Right? So this is how you can connect. Of course, the user has to know this first of all, because the user must know how to write this string first. But technically, the user doesn't have to know it. We can have a drop down. Let's say we use something like a select group, right? And what's the thing you have inside a select? Option. And option have the content value, and there is a value attribute also. So the content that you have in the option could be decision tree classifier properly written. The value could be this. So the user doesn't see it, but what gets sent is actually the value, right? Very good point. Yes, you could, and that is exactly what we were tempted to do as well. But your if-else tree will get ridiculously long. How many if-elses will you write? Like one, you can't write one for every type of thing. You will be, if you do that, so what will happen is, and it might sound crazy, but exactly how we realized, we did exactly that, which is how later we realized that pydoc.locate is a big idea, because we used to do ridiculous nonsense like this. If path dot starts with sklearn, or if, if not path dot starts with sklearn, then reject the request because we are only supporting sklearn for now. And if starts with like dot tree, then import something, it's just crazy. Because let's think about it. Scikit-learn has scikit-learn.linear model, scikit-learn.svm, scikit-learn.neural network, scikit-learn.blah blah blah, datasets, tons of things are there. I cannot recreate the entire scikit-learn tree in my code. That would be ridiculous. Which is why we use something safer. So that helps us figure out how users can pick something using which they can start creating a model from scratch. We already know how to upload data. We uploaded a CSV file, right? I can upload a training file also and I can specify a model. So I can say create a new decision tree, take this test sample, save it, and that something.pickle will get dumped. And then next I can give it a name also and then I can start drawing inferences from there. So that takes care of model creation also. Of course, we're not going into the code of all of that, but I think you've seen enough so far that you can do this, I guess. So you see this CLF over here, if I look at it, it actually has the same documentation and it's literally the same class. So it's a decision tree classifier. So I can do CLF dot fit XY. And I can say that that is my tree, or is it capital Y? Yeah. So it's my decision tree classifier is ready. And we got to this decision tree object using just a string. We did not have to actually import anything. So using this, you can create models arbitrarily. The next part is that as this happens, you'll notice that your code is becoming very sticky to the scikit-learn API. And then you'll want to support other libraries like Hugging Face, for example, or stats models for time series analysis or something, which do not follow the scikit-learn API. By scikit-learn API, I mean things like joblib.load, .fit, .predict, all of those things. Not everything has that kind of API. So how do you abstract that out? Are you going to write a different method for each time this happens? No, maybe not. So typically then, we come up with the kind of stuff that we did in the Java course, that is abstractions and interfaces. So what we ended up doing was, we support 3 runtimes. These are called runtimes or libraries. One is sklearn, and the other is Hugging Face, and the third is stats models. And there is an abstraction class on top of these, which sort of forces everybody to follow the scikit-learn API. So this is something which we call, well, let's just call it API wrapper. And what this does is, it says that, yeah, I know that Hugging Face models don't have a .fit or a .predict method, but I'm going to write a wrapper class on top of it such that it looks exactly like a scikit-learn model, right? Same I can do with this. I can force it, and it is this fellow that speaks to my server now. Or it is this fellow, this API wrapper that speaks to GramX. So now, this code doesn't care about what the underlying library is. If it has a fit, great. If it has a predict, great. If it has a score, great. That's all it needs. So how many of you have finished Java? Okay. Those of you who do Java, please pay attention to 2 things, abstract classes and interfaces. So unfortunately, Python doesn't have them. There are abstract classes, but there is no way of enforcing them. For example, Java will actually, prohibit you from running the code if your interfaces and abstractions are wrong. Python doesn't care. It's just, please go ahead and do it. But it'll not prohibit you from doing things. It's also called the language of consenting adults. So if you don't mess with it, it will not mess back with you. But good developers will try and stick to the abstractions as much as possible, because you see, I don't want this function to become too large for a simple prediction. Because here's the thing, if I've told you how to create models in scikit-learn, what if somebody wants to create a Hugging Face model? And let's say they create it, am I going to write another function called predict Hugging Face, or predict Keras, or predict TensorFlow or something, or predict Torch? No. I want one unified interface for everything, because for the user also it has to look unified, right? Which is why abstract away things as much as possible, operate on a level of abstraction. We have to make a conscious choice to say that GramX will talk to only this API wrapper. We actually had to hire somebody from Hugging Face to write classes from them to write a scikit-learn compatible API. Thankfully, Keras, TensorFlow, PyTorch all have a very good scikit-learn.api, scikit-learn compatible API. Hugging Face was kind of one of the last holdouts in that area, and they too have it now. So that's a good thing. Pretty much everything looks and behaves like scikit-learn for good reason, because it's the oldest library. And that's sort of a good interface to have for machine learning in general. Okay, so I think we are almost done. Any questions so far? Yes. Yeah. In bits and parts, yes. So there are certain UI components within Gramix. Actually, let me show you the documentation. You can always go to learn.graminer.com/guide. Yeah, or graminer.com/gramix.guide also works. So there's a bunch of different things in Gramix which you can try out. It's MIT licensed, pip install Gramix works fine. And yeah, there's a quick start tutorial. There are charts that you can do in Gramix. There are maps that you can do in Gramix. There are a bunch of different UI components there. Although I would not recommend it, because I'll tell you why the UI components are there in Gramix. We built them simply to do simple POCs and demos. I would highly recommend that you build your own UI. Use Gramix simply as a convenient web server. That is where the strengths are. It doesn't mean that the UI components are bad. You can start with them, but slowly phase them out also. Yeah, absolutely. Yeah. So what we did today, except from a couple of these tricks like gramix.cache.open and what else? Yeah, methods. And this sort of this is essentially just syntactic sugar. Gramix is simply something that knows how to interpret this and generate code on its own. If you use Flask or Django, you will have to write everything yourself. You will have to write that pattern matcher yourself. You will have to ensure that, now for example, that XSRF cookies _ false. How to do that in Flask and Django is probably going to be more and more Python code. So this is just easy. It's simple. Specifically well suited for a workshop like this, because we don't really want to get into the details of what a web server is supposed to do in the first place. Like those implementations, is something that we want to be taken care of automatically. Yes. Yes. Cross-site request forging. Yeah.
Kevin, for me, the most amazing part is in 2 hours I can set up everything.
You can do CRUD on ML models pretty quickly, yes.
The concept itself, I was one of the questions actually an action. That's great. So now I can at least understand when I talk rapid prototyping, it doesn't really just out.
Yes. Actually, just like we have a function handler in Gramix, there is also something called an ML handler, which is basically literally the same thing disguised as a handler in itself. There is an NPTEL course on this for which you can get a certificate. Unfortunately, no credit, but it's a certificate course, building machine learning apps rapidly. And I think I have a working version of this. So this is like an admissions data set, depending on certain characteristics of people, whether they'll get admitted to university or not. Their GRE score, TOEFL score, rating of the university, SOP score, letter of recommendation score, the CGPA, whether they have done research or not, or whether they were admitted or not. You might want to include name or not include it depending on your model as a training parameter. So what you can do is, let us try this. I'm going to change this thing to ML handler. And I'm just going to use the default URL. Let me quickly say x.shape is, well, yeah, so pd dot, or I can just do x label is y, or rather y. So my x dot head looks like ABCD label, right? I'm just going to save this quickly as to CSV, iris dot CSV. Again, index is false. And just like for a function handler, you have all of these things, right? You need to tell it what function to run and all that. Instead of all of that, for an ML handler, we have a different configuration. What happened to this? Yeah. Okay, there is a data URL, so I'll say that my data URL is $yamalpath.iris.csv, which I'm saying that in the current directory find a file called iris.csv. Then I can tell it about my model, so I'll say something like model class is logistic regression. This is the on the Titanic that data set, but I'll just say that target column is label. All of that is done. I can just go to localhost 9988 and see what it throws up. Whoa, something went wrong. Oops. Illegal hardware instruction. What just happened? Now I have a UI which lets me try out different apps. So basically, the kind of things that we've been discussing for the past 2 hours, they've all been compressed into this one thing called ML Handler. And it is while building ML Handler that we ran into all of this trouble. How do you sort of create a concise API for everything? And yeah, so something is up. I can't see my data. Okay, but yeah, I have my columns. I can pick which one is supposed to be the target column. The default is label because I told it in my config that it's label. I can exclude certain columns. I can mark certain columns as categorical, which will then automatically be one hot encoded. And numerical columns will be standard scale, normalized to have 0 mean and unit variance. And I can pick a model. This is a classification problem. So I've got all of these simple models. This is exactly that drop down that we were referring to, right? So when I train this, something is up. I think it's something is wrong. But anyway, you see I train this. I'm getting these 200 and post action score, accuracy metric, and so on. And if the UI is not perfect here because I clearly forgot to install something or the other. If I train, you see that I have this keyword called action which tells it, whether it is supposed to train or predict or score or things like that. It comes back with a training score of 0.9. So training score is practically useless. You need to have a cross-validated score. So there are ways of enabling that also. There it is. So this is, the kind of thing that it culminates into. And this is just a sample app to show how to use GramX in the first place, because most people want their own interfaces. So, which is another reason why we're sort of slightly pulling back on the UI components, because people want some very specific things in their UI. So it's best to sort of custom make everything. And earlier it was that people needed UI components very fast, and now because of things like the kind of stuff that you learn in Mat2, React or Vue.js, and there are lightweight web components available so easily that it doesn't make sense to componentize and standardize everything. It's already there. Okay, so I'll be around for pretty much rest of the day. Do look me up or ping me or call me whenever you need me. And if there are any questions, I'll be happy to take them. What I'll do is I'll put all of this code on this GitHub workshop. I'll also probably write a short README file. See, and I think what would be useful is if I put in some exercises with solutions. And if you could sort of follow through with that, that'll really help me. So I'll leave my email address here. Feel free to write an email to me whenever you feel like, and give me a week. I'll send out the exercises, and if I don't, please remind me.
Hello. So I hope you enjoyed the session. I know many of you are at foundation level and the things which he is saying may go above your head. But it's fine. I mean, just go through it, and after this session, it's just a beginning. Okay. I mean, just after this session, whatever he has said, he will be sharing your the GitHub link and all the contents will be with you. So once you, after this paradox, once you go home, just try it out and check all those things again. Okay. These things will make more sense when you will do it on your own. Okay. Otherwise, currently you might be feeling this is too much within a 2 hours. He explained so many things. So that will help. Okay. And apart from this, I think, yeah, we will have one group photo also. So yeah. Huh? Yeah. Yeah. So we will have one group photo. I think you guys can come together at the front. Then we will have it. Okay. Okay. Thank you, everyone. Just clap for him.